talking about chemical versus physical change, it's really important that we first start with some examples and then we can work on defining this one together. So, what is something that we can physically change? I want you to think, like, right around the room, what are some of the things that we can physically change them? What do I mean by that? What if I had paper in front of us? What could you do to that paper? Great, we can rip the paper, so we can tear paper. My question to you is paper the same when you tear it? Is it still paper? Or does it change into something else? No, so it's still paper. What's something else that, like paper, we can do something to it and it still is what it was at the beginning, but it might have changed in some way, shape or form?
Snap a pencil. Take off an apple.
Yeah, take the lid off a pen. Now I've got two things though. What is? Snapping a pencil, sure. Chopping an apple. Instead of thinking about splitting things into two, could I ever change something in some way? Think about the paper again. What could we do to paper? Instead of tearing it, we could scrunch it. So another example, I'm going to make it a slightly different one, is crushing a can. Okay. Now the final example that I'm going to put in this box, okay, last one, is a little bit tougher to think about. But what if I had my metal can and I heated it up really, 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 really hot, okay, and it melted? Would that still be the same metal can, or would it be different? Would it be metal still, or would it be something brand new? What do you think? Or another example, think about water. Water, if we put it in the freezer, what does it become? Now, is that ice still water at the end? Okay. So when we're thinking about physical changes, we can also have things like state changes. So I'm going to have ice melting. And the reason that I can have ice melting here is, at the end of the day, ice is water, just in a solid form. And water, when it's in a liquid form, is what we call water. But has it changed into a different chemical? Is it now gold? No. Okay. We could make a lot of money if we could just freeze water and turn it into gold, right? So, what is our definition of a physical change then? How could we define this thing? What do you think? Chat to the person next to you. You got 1 minute. How could we define these things? Go. Physical change, okay, is where the object itself is still the same thing at the end. So, with a physical change, there is no change to the chemical, and I'm going to include a word here, composition. Okay. Only the physical form changes. So an example here, okay, and the final word that I'm going to add is that a physical change is reversible. Okay. Now, you're probably thinking, yeah, if I tear a piece of paper, I can't magically reverse that, right? But could we break that paper down and reuse the paper and eventually stick it back together? Sure. Okay. When you crush a can uncrush a can? Yeah. Is it perfect? No, but can you do it? Yes. Yeah. Okay. And ice melting, can you then freeze that water again once it's formed? Yeah. Okay. Chemical changes, not quite so simple. Chemical changes are a little bit different. So when we talk about a chemical change, it is something which is not reversible. So the example that I'm going to start us off with, and we'll do one or two examples in addition to this one, is baking a cake. Okay? So chemical example, baking a cake. So I really like cake. I really like lots of sugar in a cake. But what are some of the other ingredients in a cake? We've got sugar, flour, egg, butter, milk, maybe even chocolate, okay? All the good stuff, right? Now, when you add all those things together and you mix it, if you really wanted to at that point in time, you could probably separate them, okay? Would it be tricky to do? Sure, but you could separate them. But when you bake the cake, can you unbake a cake? No? Could you take a cake out the oven and decide, actually, you know what, I just want my eggs back, put the cake back into the oven and it magically unbakes itself? No, we can't do that, right? When it's a cake, it is now a new thing. All of the chemicals have recombined. Okay. What's another example then of something that does a chemical change maybe? Any other ideas around the room? Mentos and Coke. Awesome. Okay. Mentos and Coke, we add Mentos to a Coke bottle, it erupts. Okay. The other example that I really like is elephant toothpaste. Has anyone seen elephant toothpaste before, where you add like potassium iodide to hydrogen peroxide and it just erupts up? So I really like that example. We'll go Mentos and Coke. And maybe even the final one, did anyone ever add bicarbonate soda to vinegar as a kid when you made like a volcano? Anyone ever make any of those volcanoes?
Yes.
You did that last year?
Yeah.
Oh, win. Awesome. So that's another example for us. So I'll write bicarb and vinegar. Okay. So when we look at our definition for physical, we said there is no change to the chemical composition, only the physical form changes and it's reversible. Okay. I don't want to say that we're going to flip this definition, but we are going to write much the opposite here. So in a chemical change, the chemical composition of the, what are we trying to say? Of the reactants changes, forming new products. Okay. Forming new products. So, when you've baked a cake, when you've added Mentos to Coke, and when you've added bicarb to vinegar, what are some of the things that you've noticed? We're going to list 4 here. So 1, 2, 3, and 4. There's actually more than 4. But what are some of the things that we've noticed? What happens in some of these reactions? Okay, awesome. There can be a change in colour. Okay. So this is particularly notable in the case of a cake. If you have raw cake batter, it might be really light brown maybe, and then when you bake the cake, it turns to a dark brown. Or even something simple like cooking toast, right? When you put the bread in, it appears white at the start if you use white bread, and then by the end, if you cooked it for long enough, it could turn black. Okay. What else? We've got colour change. Anything else that you might observe with Mentos and Coke, perhaps? What might you notice? Yeah, there might be some sound produced, sure. Changes texture. What's actually produced with the Mentos and Coke? What do we make a lot of? Fizz. And what's another word for fizz? Yeah, okay. So we can have a gas produced. Okay. We can have a gas produced. And this is a really tough one. In the case of maybe baking a cake or even throwing wood on a fire, what do you notice about the fire? It can feel hot, okay? So there can be a change in, very good, okay? Any other ideas that we've got around the room? What do we think? One more thing that you might notice in any of these reactions to show that there's been a chemical reaction. Yeah?
It might become thicker or thinner.
Thicker or thinner? Yeah, the viscosity might change, yeah. Yeah. We're going to include smell in gas produced because some gases do have a smell, you're right. One person mentioned it earlier and it's something that we might notice with our senses. What do you reckon? You can have the production of a sound, okay? So we can also have the production, okay, of light is produced. Now the only one that I'm going to cross slightly here, and I'm going to put a line through it like that, is because I want you to think about tearing paper, crushing a can. Do those things make sound as well? Yeah, so they're not going to be distinct for us. Light being produced, okay, is quite special, okay? So we can add 2 things together. Or have any of you used those glow sticks before, where you grab the glow stick and when you snap it, all of a sudden 2 chemicals join together and they make light, okay? So here's where the main part of our lesson starts now. Okay, so let me hit